Welcome to a tutorial on how to procedurally generate and texture terrains in Unity. This is a finished example of what your terrain should look like at the end, and let's get right into it. So to start out, you're going to need a terrain. To do this, you click on the Terrain tab and create terrain. This should give you a generic bland white tile, but fear not. Oops. Wrong one. But fear not, for we are going to transform it. So the first thing you're going to want to do is assign some textures. So to do that, you click the Edit Texture and Add Texture buttons, and select. I have the default environment textures loaded here. So you're going to want at least two. So pick out two of your favoritist textures and be sure to remember the order they're in. It'll come in handy later. So the only other thing you need to do is create a script that takes a few octaves or layers of Perlin noise and maps the points, or maps each point of this terrain to a point on the texture that we create using Perlin noise. So to do that, I will walk you through the script that we have here. I don't want to write out the whole thing. It'll take 40 minutes or so, but I'll be as in-depth as I can. So before you do anything, make sure you have the using system.link tag up at the top, and we'll need a good handful of variables here. You'll need a terrain and a terrain data variable. You will also need a width and height integer for each point on the terrain. You just call it height map, width and height. And then you'll need floats to represent the different octaves of Perlin noise. We're going to randomize them right here actually. But basically what the octaves do is they kind of give a scale for the Perlin noise. So you can either have a low number that'll give you large gaps in values, or you can have a large number that'll give you very small gaps. So you can have kind of levels and different levels of detail depending on how many octaves you have and what numbers are in those octaves. It's something you really just have to play around with. We're using 4 here. You can get away with as low as 2. 4 is kind of a good number just for kind of a generic, as you can see. Enough that it gives the illusion of naturalness, but not so much that you have a bunch of code. It's not that difficult to add more. You just copy and paste a few lines of code and you have another octave. But again, we're just going to stick with 4. So in the start function, you are going to check if there is terrain. So if no terrain, then we'll assign the terrain. You could do this by just dragging and dropping the terrain in, but it's not professional enough. We're fancy here on this channel. So after that, we're going to assign the height map width and height map height to the corresponding numbers in actuality. So terrain data, height map width, height map height. After that, we will randomize the octaves in between values that we want. You can make this completely random and just have your terrain all over the place, but it's generally a good idea to find a number that you like and randomize between 1 to a half a point away from it. So in the case of this octave, I found that 2 was a good point for me, so I went in between 1.5 and 2.5 just to give it a little bit of a pizzazz, so it won't turn out the same way every time. So once you have your octaves, you just want two functions. You're going to want a function that generates the terrain and a function that paints the terrain. And we'll now get into each of those. So for generating the terrain, we are going to want a double or two-dimensional float array that will contain our height map data. These are each of the points along the terrain, and we are going to set that to a function called getHeights, and you're going to plug in the height map width and height into that so it knows how many points there are. Once you have that, you're going to make a double nested for loop, and for each octave or for each layer of Perlin noise that you have, you're going to need one of these blocks of code. And essentially what this does is that it creates a vector2, which is just a variable with two numbers in it, and you go through and you assign the octave number divided by the width of the entire terrain plus an offset if you need it. The offset will essentially move the Perlin texture around. This can add in further randomization if you need, but for now this is actually 0, so you don't actually need it, but it's nice to have. So you're going to do that for both the x and the y portions of the vector2. So octave divided by width and octave divided by height. Both of these are multiplied by your x and your y, your current position in the height map. Alright, so once you have that block of code for each of your octaves, so we have it 4 times, you're going to access your height map two-dimensional array, and you're going to assign as they come. So this is going to be run each time this inner for loop goes around. So at each point we're going to set the point equal to the addition of all of these vector. Essentially we oh, I kind of forgot to mention that last part, didn't I? Anyway, I should probably go back to that. After we have this vector2, we put it into a float, so we can use it as a usable number. And this is actually what runs it through the Perlin noise function. So all you have to do is plug in the x and y of the vector2 that we created through this mathf Perlin noise function, and that'll give you your actual height. Okay, now that we have that, you add all of these heights together, these Perlin generated heights, and that will give you your actual height, and that will be stored in the array. Here I have some fancy stuff that makes it a little more mellow, I guess is the word. Dividing the number by an integer will tone down the effects of that particular octave, and will give you a much smoother terrain. So the big what was it? Yeah, in between 1.5 and 2, so big wavy Perlin texture is going to be divided by a relatively low number, while the 5 and the 9 waves are both divided by 130, and then the other low one is divided by 20. These are just personal taste numbers. You can customize them to your liking and whatever you need. Normally, when you generate terrain, you're going to want some mountains in the background or something of that nature, in which case you would lower these numbers and get a much rockier, much more defined map. But for nice rolling hills, you're going to want some big numbers to divide these heights by. So at the end of this loop, you're going to set the terrain data and all of the heights of the points in that terrain data to the array that we have here. You just plug in the array and it'll set all of the heights of the points in the terrain to the heights in the array. And that will basically create your entire terrain. So that part is now done. To paint that terrain, you are going to make a 3-dimensional array, and you're going to call that, it doesn't matter what I call that, but this is going to essentially create a what's called a splat map. And what we're basically going to do is we're going to load in all of the textures that we've assigned to the terrain and alter the transparency of them. And depending on what parameters we assign, some textures will show through more, some will show through less. I have mine set on steepness and one just set as a constant. But you can do it by height, you can do it by steepness, you can do it by whatever your heart desires. So to begin, we need 2 floats. Again, these are going to be normalized floats based on the height and width of the terrain. So you just do your Y counter and your X counter divided by the height and width. So we're going to have a height variable. I don't think we actually use this in this. No, we don't. But height is a good number to have around. Just a reference to how high you are on the terrain. And we get this just by getting the height, and we do some other fancy stuff with normalizing and routing to integers and that sort of such. You can pause and copy if you need. So that gives you the height of the terrain. Moving on to the steepness, we get a steepness variable via the getSteepness function, and all you need to do is plug in your X and Y into that. It gives you a nice steepness, so you can have texture show up on walls or degrees of certain angles. And once you have a height and a steepness or whatever else you want, you're going to want an array of weights, and these weights are going to determine how much a certain texture shows through. You just plug in your terrain data alpha map layers, that's what they're called, and we're going to create 2 of them because we have, as we recall, we have 2 textures, and all we need are two weights. The first weight I have just as a constant, so it will always show through at half transparency, or on areas where there is no other texture. It'll just be that texture, and that's just a good baseline to have. Excuse me. And the second one will be based on steepness. This is a fancy equation that just says if it's steep terrain a certain steepness, then apply height map this much terrain data dot height map dot height divided by 5 times the steepness squared. And that's this equation works for a relatively flat terrain. If this was, spiky and mountainy and rocky, it wouldn't work too well. But you, if that's something that you want to do, you just modify the division here. Generally, I forget exactly. I think generally lowering the number will give you a little bit more control. As in, it'll register that it's deep enough sooner. Okay. So after that, you're going to want to sum the two together and apply them here. But before that, kind of hard to explain. It gets a float for each of them, and then it normalizes that float to 1. Just so that you have an even distribution of the textures. So once you have that, you just set it, terrain data set alpha maps, and then you plug in your splat map data, which is these two values. And there you have it. A nice procedurally generated, randomized, as you can see it has slightly randomized values, as discussed before. And there you go. Hope this was helpful in some way. And I'll see you guys later.